Okay, so in this separation problem for the conservation of momentum, we have a rifle firing a bullet with a very small mass, just 0.035 kilograms, and this bullet leaves the barrel with a positive velocity of 304 meters per second. So let's draw a very poorly rendered firearm. We'll draw it like a pirate or something like that. I don't know. It's a gun, right? With the bullet, very small mass, we'll call it M1, 0.035, with a very large velocity of 304 meters per second. Now, in terms of the mass of the gun, we're not given that. We're given the mass of the rifle and the bullet is 3.31 kilograms, which means that if we want just the mass of the rifle itself, we need to subtract off the mass of the bullet. So 3.31 minus 0.035 is going to give us the mass of the gun being 3.275 kilograms. That's a small little twist on this problem that will kind of make your life difficult. Because if you were just trying to use M2 as 3.31, you'd be close, but you wouldn't have it exactly. Okay? And we know this gun, whenever you shoot it, it's going to kick backwards at some velocity. We don't know what that final velocity will be. That is what we are looking for in this problem. And we know initially, whenever you're just holding the rifle there, you're aiming at your target, trying to be the marks person that you are, you're initially, for both the gun and the bullet, at rest. So we know that initially there is zero momentum in this problem. So we know the initial momentum is 0, and that means that when we set this up to equal the final momentums, adding our two momentum quantities together, we know they have to add back to 0. So we're going to say here that 0 equals, and this will be the final momentums of the bullet and the gun, the mass of the bullet, 0.035 kilograms, multiplied by its velocity, 304 meters per second, plus the mass of just the rifle, the 3.275 kilograms, multiplied by that unknown rifle velocity, which is what we are looking for. So at this point in time, we just need to solve this out. We need to multiply these two numbers together to get some quantity here. If we do that, we would get 10.64. Then we need to subtract that 10.64 onto each side. So it goes away from here, and we get negative 10.64. That's going to equal the 3.275 kilograms times the second velocity. And then if we just divide now by the mass of the rifle, 3.275, we find the velocity of the rifle to be a value. It's negative because it's just recoiling in the opposite direction of positive. And we find a value of approximately 3.24, 3.25 meters per second. So that value we got there of 3.25 or 3.24 whatever meters per second, that negative, that recoil, that kickback, that is our velocity. Sometimes people like to shoot heavier guns because there's less of that velocity, that kickback, the recoil into their shoulder. But you can also find videos of fools shooting shotguns online, either one-handed and they'll break their wrist immediately because the recoil is so large, or they'll hold the shotgun in front of their face and fire it, and it's going to recoil back. So be careful out there with your firearms, people. But this problem is finished. Next time we take a look at conservation momentum, we're going to look at problems where objects are moving initially and they're moving after their interactions. But until then, adios, and take it easy.